This is tutorial number 15 on the resistor color code. If you think you know the resistor color code, you might want to skip this tutorial and go straight to drill 12 and test yourself. And if you do well, move on, save yourself a little bit of time. But you do need to remember the resistor color code and how to use it. There won't be too many questions in your assessment on the resistor color code, but you could get one or two. And that's 4 marks that you really don't want to lose. On screen is a chart of the resistor color code and how to use it. And I'm going to put this chart in the document folder of your DVD. It'll be a PDF file, so you'll find it there and you might want to print it. Before we go on to how to use the colors on a resistor to tell what its ohmic value is, we really need to learn the color code and commit it to memory. You will not have access to the color code in your assessment. Now, if we look down any of these vertical columns, we can see the color code. We have the basic color code is black, brown, red, orange, yellow, green, blue, violet or purple, but it's usually called violet, grey and white. That's the primary color code there. The other colors that you need to remember is gold and silver, and I'll explain what they're for shortly. But primarily we need to find a way of remembering these colors and what they represent. Black is 0, brown is 1, through to white, which is 9. And I might be able to help you with a little ditty to remember those colors. Here's a rhyme that I learnt. It's not quite the same. The one I learnt is a bit unspeakable these days, or not politically correct, so this one's been tamed down a little bit. Big boys race our young girls, but Violet generally wins. If you can remember that sentence, practice it and remember it, you'll be able to go into the assessment, write it down, and then use the first letter of each word to be able to write the color code, which I'll put on the right hand side of the screen. Big is black, boys is brown, race is red, our orange, young yellow, girls green, but blue, violet, generally grey, wins white. Big boys race our young girls, but violet generally wins. Commit that to memory and you're halfway there to understanding the resistor color code. You do need to remember the colors. Going back to the chart. So we've now learned how to remember these colors. Big boys race our young girls, but violet generally wins. And you also need to remember gold and silver. But before we get into how to use the chart, and I'm reminding you again, this chart is in your document folder. One of the confusing things about reading resistor color codes is which end of the resistor to start from. These aren't particularly good examples, but they'll do. You will notice that on any resistor, the colors are bunched up to one end. There are more colors up towards one end than there are up the other. So in the case of this resistor, we read from the left end. If I rotated the resistor through 180 degrees, we'd be reading from the right end because the colors are bunched up towards the left-hand end as it is now. Similarly, down here with this resistor, the colors are bunched up towards one end. So that's the end that you begin to read the colors from. There are two different ways of using the code that we need to know. Some resistors have a 5-band code. You may get a question on 5-band, more likely to be on the 4-band code. I would certainly know the 4-band code, but it's basically the same code, so it won't be a problem. Right, let's have a look at the top resistor. It says what the value is here, 237K, which is 237,000 ohms, and the tolerance is 1%. That means that this resistor is this ohmic value, 237K, but that value could deviate by plus or minus 1%. There are different tolerances. There's 1%, 2%, 5%. It's very rarely to get 10% or 20% these days. Usually it's 5% or better. So, looking at 5-band, the first colour on the resistor is the first figure of the ohmic value of the resistor. So the first colour is red, so the first figure is 2. So we write down 2. First is red, red is 2, we write down 2. The second colour is orange. We go to the chart, orange is 3, and it's the second figure. Orange is 3, so we write down 3. So red, 2, orange, 3. Same again with the third figure. What is the colour? The colour is violet. If we haven't remembered it, we look at the chart, we go down, violet is 7. So we write down 7. So the first 3 figures, colours, we just write down the number. Red, we write down 2. Orange, we write down 3. Violet, we write down 7. 237. The fourth band on the 5-band resistor colour code is the number of zeros to write down after we've written down our first 3 significant numbers, our first 3 significant figures, which are 237. Now the fourth band is orange. Orange is 3, so we have to write down 3 zeros. If we put 3 zeros after 237, we get 237,000. But we've written K instead, 237K ohms. Because the fourth band is orange, it means the fourth band is how many zeros to add. There is a deviation of that. If the fourth band is either gold or silver, we have to multiply by 0.1 for gold or 0.01 for silver. Now you'll rarely see silver. So if suppose the fourth band was gold, that would mean multiply 237 by 0.01, which in effect means move the decimal point 1 place to the left. So if this resistor was red, orange, violet, gold, that would be 237. Move the decimal point 1 place to the left, it would be 23.7 ohms. You see what a big change the fourth band makes on the value of the resistor. But in this case, our fourth band is orange, and that's add 3 zeros, so it's 230,000 ohms. The last band on the 5-band code is the tolerance of the resistor. On this resistor, the last band, and we know it's the last band because these are all bunched up towards one end. The last band is brown, and brown is 1, and that means 1% tolerance. If it were red, that would be 2% tolerance. And there are other high tolerance resistors and colours that we can use for them, but you won't be tested on that. You'll have the chart to look them up in your amateur radio experiments if you ever need to. If the last band is gold, it's 5%, silver is 10%, and so on. But on 5-band resistors, you won't find gold and silver. You'll always find usually brown or red for 1 or 2% tolerance resistors. So I'll just go through this one quickly again. It's 237,000 ohms, 1%. And we get that by red is 2, 2, orange is 3, 3, violet is 7, 7, and orange is 3, so we add 3 zeros to make it 237,000 or 237k, and the last band is brown, which is 1% tolerance. Not that hard. Just needs a little bit of practice, and once you've done a few drills on the resistor color code, you'll find it's not too hard at all. Let's have a look at the 4-band resistor color codes, very similar to the 5-band. Again, we read the resistor from the left-hand end because the colors are bunched up towards the left-hand end. And this resistor has the colors yellow, violet, gold, and I think that's gold. Yes, it is. Bit hard to tell the difference sometimes between gold and yellow. You have to be very, very careful on some resistors. Okay, well, the first band is exactly the same. The first band is exactly the same as the 5-band. It's the first significant figure. So yellow is the first band. Yellow is 4, so we write down 4. The second band is violet. Violet is 7. So we write down 7. The third band is the, actually I've made a blue here, it's not, the third band is not gold, that's yellow. Bit hard to tell the difference between gold and yellow. So the third band is the multiplier. This is how many zeros to add, or whether to multiply by 0.1 or 0.01. If the third band is gold, you multiply by 0.1. If the third band is silver, 0.01. But in this case, the third band is orange, and that means the number of zeros. So orange is 3, so it's 3 zeros. So 4, 7, and 3 zeros, because that's orange. That's 47,000 ohms. And the last band is gold, and that's a tolerance of 5%. Suppose this were yellow, violet, gold. Well, that would change everything completely, because we've got a gold third band rather than an orange third band, which means add 3 zeros. A gold third band means multiply by 0.1 or move the decimal place 1 place to the left. So we would have 4, 7, and then move the if that were gold, move the decimal point 1 place to the left. That would be 4.7 ohms, not 47,000 ohms. Well, there you go. This is in your document folder. There's not an awful lot. It's not that hard, the resistor color code. Commit that ditty to memory. Black boys race our young girls, but violet generally wins. Write it down as soon as you go into your assessment, and you'll be able to work out the values of resistors on your paper. And the good thing is too, you've got a multiple choice as well. But do commit the resistor color code to memory. I won't be going through any exam questions with the resistor color code because it's fairly pointless. You have the drill. You've got drill number 12 on the resistor color code. There's not much more to know about it. I'd suggest that you go into the drills after you've committed the color code to memory. A good idea to print it and refer to it as you're doing the drills, and then later on not refer to it and see if you can do it without any reference material. Thank you for listening. This is Ron, VK2DQ. I'll catch you next time. Cheers for now.